Let's solve lead code 21, merge two sorted lists. You are given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. So here's an example. The first list is 1, 2, 4. The second list is 1, 3, 4. When you merge them in sorted order, you're going to get 1, 1, 2, 3, 4, and 4. So let's see how we can solve this problem. Here is the first list. Here is the second list. Again, visualize this problem from the perspective of you're creating a new linked list by moving the nodes from the original linked list into this new linked list. So how can we solve this? Here is list 1, here is list 2. Basically, we need to compare the values stored in the nodes pointed to by list 1 to the values stored in node that's pointed to by list 2 and take the smaller one. Because they are equal in this case, it doesn't matter which one we take. We can take this one or this one. So let's take the one that's stored in list 1. So what we are going to do is we are going to have a temporary node pointer pointing to this node, and then move the list pointer pointing to the node that comes after it. Now this node can be appended to the end of the new linked list that we are creating. So we are going to take this, right? We are going to take this and append it to the end of this new linked list. Because it's empty at this point, we can just append it, right? Make both head and tail point to the node. So we continue. Again, we now continue, come back to the beginning of the while loop. Again, we compare 1 to 2. 1 is smaller. So we're going to make now node point to list 2, move list 2, right, to the next node, and then take this and append it to the end of the new linked list that we are creating. So basically, this is what we are supposed to do. We need to just append it to the end and continue like this. So now 2 and 3, so we should take 2, and to do that again we make node point to here, move list 1 pointer, and then take this and append it to the end of the new linked list that we are creating. So that's how it's going to look like after this append operation. And next we'll take 3, then we take 4. As you can see, at some point, one of the linked lists will finish up, right? At that point, we're going to get out of the while loop and just append the rest of the remaining linked list to the end of the new linked list that we are creating. Of course, after we append anything, so we have to move this tail pointer. So I forgot to show that. So let me write this code for you. So we first of all create a new linked list. Let's call down list node, new head is equal to null, new tail is equal to null. So our while loop continues for as long as list 1 is not equal to null and list 2 is not equal to null. So we compare, let's declare our list node, which is null at this point. So let's compare the values stored in list 1. So if list1.value is less than or equal to list2.value, then we are going to take the node pointed to by list 1. Otherwise, we are going to take the node from list 2. So we're going to say node is equal to list 1, and then list 1 is equal to list1.next. So basically taking the value, the node pointed to by list 1 because it has the smaller value. Otherwise, we're going to take the node from list 2. So this time it's going to be list 2 moving. So apparently I forgot the 1 in here. So when I come here, now I have node pointing to the node that I would like to append to the end of the new linked list that I am creating. And the special case is if new tail is equal to null. If this is the first node that I am appending to the end of the new linked list that I am creating, then I need to say new head is equal to new tail is equal to node. Otherwise, it's the regular append code. So how do I append something to the end of an existing to the end of a linked list? We say new tail dot next is equal to node, and then new tail is equal to node. That's it. So when we get out of the while loop, this is the end of the while loop. Either list 1 or list 2 must be empty. I don't know which one. So what I'm going to do is I'm going to check if list 1 is not equal to empty. So if there are still nodes to be appended from list 1, then I'm going to say new tail dot next is equal to list 1. Otherwise, that means there must be nodes from the second list. So I'm going to say new tail.next is equal to list2, and finally return new head, so head of the new linked list. Of course, there's a special case in here, which is if any of these linked lists are empty to start with, then we should return immediately. We should not continue. So if list1 is equal to null, then we should simply return the head of the second linked list. Because think about it, if list1 is empty, then there's nothing to get from list1. We can just return list2, which is already sorted. And we should also do it for list2. So if in case list2 is empty, then we can just return list1. So those are the two special cases that we have to put at the top. So let's just run this thing and then submit. And let's see if it works. It should. Yes, as you can see, it works. So again, we are applying the same idea that we applied in the previous linked list questions. We visualize the problem from the perspective of moving nodes from the original linked list into a new linked list that we are creating. So this is our new linked list that we are creating. So within the while loop, we just look at from which list am I going to take the node and append it either to the beginning or end. So in this case, we are appending it to the end, but in some problems, you are prepending it to the beginning of the linked list. So node is here. I don't have to initialize it to null. You know, when you declare a variable in Java, it's automatically initialized to null. And either we take it from list1 or from list2 and then simply append it to the end of the linked list. And in here, when we get out of the while loop, at least one of these linked lists must still have nodes that have not still been copied to the end of the linked list that we are creating. We do that and just simply return the head pointer. So that's your merge two list solution. And any questions you might have, just leave them in the comment section.